So previously we talked about the vector functions, right? We say a vector function, it's a type of the rule, it's a type of the machine, which is going to get one number as input, a scalar as the input, and multiple numbers as output, a vector as output, right? Input is a scalar to our function f, and output is the vector, right? Okay, so let's consider some examples here of the vector functions. So if we're given a vector function in the form this 3 minus t, 5 plus t minus t, this is an example of the vector function, right? For example, by substituting different values for the t, we can find the different vectors, right? Or different points, okay? So when the t is equal to the 0, what is the r of t, r of 0? It's going to be 3, 5, and 0, right? When the t is equal to the 1, what is the r of 1? It's going to be 2, 7, and minus 1. You see, so by substituting one number, we're getting a vector, right? So we can even draw these vector functions when we look to these vectors, output vectors, as the points, right? Okay, so let's consider an example. So another example of the vector function is r of t is equal to the cosine of t, sine of t, and the t. Okay, so this is three-dimensional curve. So do you remember if I wouldn't have the t, the third component, cosine of t and sine of t would be just a circle and td, right? Here, by choosing the different values for the t, we can put the points, right? So let's, instead of drawing a vector, because they're confusing, right? So when you choose the different values for the t, you're going to get the vector, right? For example, when the t is equal to the 0, you're going to get a vector with the components 1, 0, and 0, right? And instead of drawing a vector, we will just trace the ending points of the vectors, okay? It will help us to draw this curve, okay? So the difference between the equation of the circle, the parametric equation of the circle, and this one is that by changing the t, so you're changing the z component of the points here, right? So previously, you were on one, so if you wouldn't have the t, it means that all the points, cosine of t and sine of t, are on the same plane on the z, right? They are on the ground. Now, if you're increasing the t, it means that you're going up, right? For example, if you substitute t to be equal to the 5, it means that you're 5 units upper from the ground, above the ground. Do you understand this? If you substitute t to be equal to the minus 2, it means that you are minus 2 level under the ground. Do you understand this? By substituting the t, we are like a circling around the z-axis, and we're going up or down. Okay? So can you imagine this graph? It is going to be like this, okay? So where the radius is going to be equal to the 1, right? Okay? Do you understand this? So this kind of curve is called helix. This is the curve of the helix, and this is the vector equation, or you can call this as a parametric equation of the helix. Okay? So for us, it is important to define the vector equations, and at the same time, it is important for us to do some calculus with the vector equations. Okay? So what we're interested in is to find the derivatives of the vector equations and the integrals over the vector equations. Okay? So let's start with the derivatives. So before we can define the derivatives, we need to define the limits. Right? So let's say if we're given the parametric equation, the vector equation, is these three components, where every single component is a function of the t, right? It's going to be f of t, g of t, and h of t. Okay? And if you would like to find the limit of t goes to some constant a, where of this vector function, r of t, this is again the vector where every single component is the limit. Okay? This is going to be the limit of f of t, where t goes to the a, the limit of g of t, where t goes to the a, and the limit of h of t, where t goes to the a. Okay? For example, so if the r of t is given as, so cosine of t, t plus 3, and t squared plus 3t. Okay? So what I want is I would like to find the limit of r of t where t goes to the 0. Okay? So again, if you would like to find the limit of the vector function, you are going to have as output a vector again. Okay? So in order to do this, we need to find the limit of every single component separately. So we are going to find the limit of cosine of t, where t goes to the 0, the limit of t plus 3, where t goes to the 0, and the limit of t squared plus 3t, where t goes to the 0. So what is the limit of the cosine of t when t goes to the 0? 1. What is the limit of the t plus 3 where t goes to the 0? 3. And what is the limit of the t squared plus 3t where t goes to the 0? Is 0. Okay? This is how we're going to find the limits of the vector function.